Okay, question 4. We've got a table of data from a large data set about rainfall in Herne. The first question is, why does Josh need to clean the data? Okay, if you looked at the large data sets and you looked at the things for rainfall, you'll see there's lots of entries that say TR, which stands for there's a trace of rain but not enough to work out the number of millimetres. Okay, so this would be the reason why I have to clean the data, because it's non-numerical. So TR values would need converting to numerical data. Probably 0, because it's so small it's negligible, so they'd probably just change it to a 0. Okay. B, linear interpolation to calculate an estimate for the upper quartile. Okay, most people were great on this. Okay, so upper quartile is 3/4 of the sigma f, which is 184. So 138 minus the cumulative frequency at the beginning of the group it's in, which I get to be 131. Okay. And then we divide it by the amount of data that's in that group, so there's 24 values in that group. Okay. Multiply it by the width of the group. Okay, the group goes from 1 to 5, so the width of the group is 4. Okay, then we have to add it to the amount of rain at the beginning of a group, which is 1 millimetre, so we add 1. Okay, and that comes out at 2.16 recurring. It says for 3SF, so 2.17 millimetres. It doesn't say 3SF, but I've rounded it to 3SF. Okay. C. Skipping back so I can see the question. Calculate an estimate for standard deviation. Some people got a little bit confused on this one. Okay, it is the mean of the squares. So 7704.1875 divided by 184 gives the mean of the squares, minus the square of a mean. So the mean is 539.75 divided by 184. We want the square of a mean square rooted. If you whack all of that into your calculator, we get 5.767 millimetres. Okay. D. Gets a little bit more complicated. State an assumption involved in using class midpoints to calculate an estimate of a mean from a group frequency table. This is pertinent to any question about group data, not just this one. Okay, and we're looking for uniform spread of data within group. Part 2 says using your knowledge of a large data set. Okay, we've got to realise there's a lot of these TR trace values, and there's a lot of 0. There's a lot of days when there's no rain at all. Okay, probably a lot more than there's days where it's 0.1, 0.2. Okay, so it's bottom end weighted. Okay, so lots of 0 and trace values. So first group, unlikely to be uniform. Okay, and part 3, what effect would that have? Well, if there was loads of 0s and trace values, that would drag down the midpoint of that group, drag down the median of that group, drag down the mean of that group. Okay, so the actual mean overall would be lower. Okay, so state giving a reason, lower mean as more 0 values to be taken into account. Okay, I hope that makes sense. Stay safe.